Hello. So this is not my typical video where you're going to see with proper edits and everything. No, this is a very raw video. The reason for that is I actually want to show you, what's possible with Claude. So let's just go through our first setup. Okay. Now, what do I have? Let me go through that first. So what I have are a few inputs, dead and live loads. So these are axial loads. And then this is axial load and bending moment condition. I just created like a test case using Claude itself with different allowable bearing pressure. And towards the end, it goes to 120 with different F prime C. So 32 MPa, 40 MPa, and then the cover is 50 mil. That's what we use standard anyway. Okay, so now this is our design data. And what we are going to do is we're going to take all these details and then we are going to draft it in our AutoCAD. Okay, I'm going to close it for now. And I'm going to go at VJN. Yep, you'll have all the necessary inputs to the pad footings. Let's see. Now, I'm going to keep my timer here. Let's also see how much time it would actually take. So it's going to read the Excel file first. Exactly. So it's inside my folder tools. So it's accessing my folder. So there were a few failures, as you can see. It's going through different iterations um, with different dimensions, with different reinforcements. So that was like sort of like the start of it. And yeah, let's see how it goes. See, failed after 3 iterations. BF8 failed after 3 iterations. Okay, so I had this rule where I kept it at like 3 iterations. After 3 iteration, we would go and it would come back. Otherwise, I just don't want it to go in a loop a lot. But then now it says 3 iteration limit is not enough, and it's going to go up to 10 iterations and see how it works out. Now, it just increased all the reinforcements, and right now it's going to generate like PDFs, and we could see the calculations on how the calculation was done. It says all 10 PDFs are saved, and let's see. I'm going to show the PDFs on. So these are the different pad footings. So we have got PF1. Okay, so I clearly had like a wrong dimension. Just give me a sec. That's it. So these are the different dimensions, as you can see, like 10 different pad footings with 5N24s, 5N20. So with different reinforcement used in different directions too. Okay. Okay, so 5N28, 5N28. It's like 3,000 by 2,750, and it's a 650 deep footing. I will be really honest here. I don't think it is 100% there. And then there's like a footing schedule too. So I could just copy and paste it in my drawing when I want to use it. So that's the reason why I had it build a footing schedule as well. There are a few more things that I would want to change. For example, the way I would definitely change the way how it's being shown, and I really have to go through the iteration loop. I was just a little bit excited as to show you like how we can actually use Claude skills. I mean, this is great. Think about it. And now you might be thinking, okay, this is AI generated slope or whatever that is. But here's the thing, okay? Now I'm going to show you my folder structure as well. So I've got like a specific folder in my for my Claude Code instance, and I've got like another projects. And now this is that project. VJN005, and go to calculations, and here like for the calculation sheet for all those 10 footings, so we can go back and check on how those steps were done. For example, I'm going to go with PF1. Okay, so PF1 pad description is 1500 squared, 500 deep, dead and live load, allowable bearing pressure, bearing check was done, and then so I don't really want to keep this like a structure engineering video as such. So this is based on my spreadsheet. From my spreadsheet, I turned it into like a Python script so that I could just go ahead and use it as many times I want. Now, mind you, the whole process took under 5 minutes. So it's like once I do refine it a bit more, I would sort of have like I could make like 10 different variations of a pad footing in under 5 minutes, right? So there's a little bit more work which needs to be done because I'm really thinking about it too, where the way how these dimensions are chosen and the sort of like thumb rules that we usually follow. I'm thinking about it on how to actually tackle it. So those are very, what do you say? Those are refinements which you make over time. But as a base, like as a skeleton, this seems great. So I can actually go back to the report and refer, okay, how these footings were designed. Now, I've kept the column. Obviously, all of these are interchangeable. All of these are changeable. So whatever column length we have, or if it's like a circular footing, or it could change. Allowable bearing pressure. That's it. So we can actually see as to we could go through the whole calculation as well. Like I said, these are my calculations. If you have a spreadsheet, you could definitely do this. There's nobody that's stopping you. And I suggest, I mean, you should give it a shot. So this is clearly an error. I don't think like 440 wouldn't do it. So there are a few things that, like I said, I have to refine it. I think that could have been an issue. As I said, this is not 100%. There's a little bit more work that needs to be done. So, so this is sort of like the big picture that I see. There are amazing softwares out there. There's Space Gas or Inductor or whatever that is, brilliant softwares, but we don't necessarily use them for a pad footing design or something like that. We use our own spreadsheets. So what we are doing here is we are turning our spreadsheet into a skill end to end. So next time our pad footings would be in a chat window. We could say, hey, all the loads which you get from your design software, you can bring it in and then look at it and just upload it. And Claude would go ahead and do all the analysis based on your spreadsheets, your design procedures, your design principles. So you can trust the output. It's not bullshit in, bullshit out. No, you're confusing the matter here. The AI is only running your process. It's not designing your process. You design the process and you validate it. After you validate that cycle, then you basically have a skill that you can reuse till eternity. At least this is how I look at it. Thought this was an interesting case. That's why I wanted to actually share it. And let's see how it goes.